Hello, everyone. My name is Dr. Munir Musa, and I'm a volunteer director of Global Forum for Teacher Educators. Welcome to the fourth series of free webinar, Human Rights Education. STEM is an innovative approach to education that focuses on science, technology, engineering, and math. It helps to develop critical thinking skills and improving problem-solving abilities. Later, the integration of art revised the term as STEAM education. Based on field experiences, I coined the term e-STEAM. In my viewpoint, education does not merely mean the acquisition of knowledge or participation to build critical thinking or creative skills alone. It also aims at shaping a positive attitude and instilling ethical, moral values among learners. But why do we only focus on education that offers materialistic gain? We are missing ethics. High expectations from the children to act like an angel is not the purpose of education. Rather, to value self followed by others. Teachers should avoid hammering ethical values, rather give them directions to make the right choices in life. Children must learn ethical parallel to each element of STEAM education. It can help them becoming an active citizen and take ownership of making wise decisions in life. On the behalf of Global Forum for Teacher Educators, I warmly welcome Dr. Diana. Dr. Diana, over to you, please.
Thank you so much. Greetings, everyone. I hope this finds you all well in health and spirit. And thank you so much for being here this evening. I know that for most of you, it's in the middle of the evening. I'd like to thank Dr. Munir Musa, Director of Global Forum for Teacher Educators, for hosting this event and for all of his time and efforts in hosting this particular session, as well as all of the sessions that are available for free to educators throughout the world. Thank you so much, Dr. Munir Musa, and thank all of you for being here. So that was a great introduction Dr. Munir gave prior to me coming on live, and it is totally aligned with what we're going to learn from me, your presenter, Dr. Diana, during this session. So I would like for you to be as active and engaged as possible, which is aligned with STEM philosophy. So if you could look at our first slide, if you're at home watching this, which I know you are, see if you can get a cup of water with some dish soap, a straw, an object from nature to observe. So it can be a leaf, a flower, it could be something inside your home, but preferably something from nature. And the last bit of materials are a little more trickier. How many of you are familiar with spinning tops? Probably you've all used a spinning top at some point in your life. What I want you to do, if you have something that spins, like maybe a fidget spinner or even a toy top, have that out and imagine that you're going to have the challenge of engineering, designing a spinning top during this session. So what are materials you could use that you have from within your home that you could gather up to build a simple spinning top? So we're going to get going here, but I did want to give you the opportunity to collect some materials. So I hope you are excited to be here today here with us. So our session today is all about the fact that everyone needs STEM skills. STEM skills are for everyone, no matter what sex you are, no matter what country you live in, no matter your culture. STEM skills are for everyone. And that's what we're going to find out today, what STEM really is about and how we can go about incorporating quality, authentic STEM learning experiences within our homes, our classrooms, and virtually. So would you agree with me that STEM skills are for everyone? What do you think? Share in the Facebook chat room if you'd like to. And I'm hoping you're gathering up those supplies. So I'd like to tell you a little bit about myself, your presenter, Dr. Diana Worrell-Grabowski. I go by Dr. Diana because it's much easier to say than that last name, much easier. So first of all, to give you a little bit of my background, I was raised in Southeast Asia. I grew up in Bangkok, Thailand, and Vientiane, Laos in the 60s and the 70s. And my father was not in the military. He did something else. So I lived in the jungles and lived amongst the people. It was a really exciting upbringing. So I've been involved in education for about 35 years. I've taught middle school, high school, university level science and STEM. About 35 years ago or 30, I established my own training company. And now I travel the nation and the world providing teacher workshops in science and STEM to all age of teachers, including parents. I also do keynotes. I go into libraries. And I still go into classrooms working with kids. So I think that's important for you to realize that. So now that I know a little bit about you all, I see that we have people from all over the world here. I'm just looking at this. Oh my goodness, we have so many people here. Thank you so much for being here. And I'm going to be asking you a lot of questions during this session because Dr. Diana is trying to model best practices in STEM education, which is teaching via inquiry. I want to engage and empower the participant. So my first question to you is, what do you envision when you think of STEM? What comes to your mind when you think of STEM education? So I'm going to give you about 30 seconds or so. Please respond in the Facebook chat area there. Please share, what do you envision when we think of STEM education? So I'm waiting to see what are some visions that our participants have. Okay, what are some visions? And I'm looking for chat box information. Okay, we'll keep going here. What do we see? Dr. Diana wants to, okay, beautiful. So we're going to go to our next slide. Most people, when they think of STEM education, they're thinking of technology. They're thinking of robotics. And it is so much more than that. The slide that I have in front of you, which hopefully will catch up here on the screen, shows you a student working with robotics and technology. This is very expensive, but it is not only what STEM represents. And our goal here today is to figure out how we can incorporate STEM in an authentic way, a quality way, so that everyone has an opportunity to experience STEM education. So what does STEM stand for? In the chat box, if you can share for me and the Facebook page, what does STEM represent? So what does STEM represent? I'm waiting to see your responses. There's a little bit of lag time here, so it's a little difficult. Okay. So, and my global forums on my laptop is not showing anything, so I'd really like to see how we're all participating so that it makes it a more engaging session here. We've got some lag time and I'm going to go, here we go. Let's see, hopefully it's going to be starting here. So I gave you a moment to share what you believe STEM stands for. And I see a beautiful science, technology, engineering, and mathematics. Beautiful. That's what I was looking for. So STEM stands for science, technology, engineering, and math. And I have 4 photos here that represent a lesson that a teacher could bring into the classroom or virtually or within the home. And it shows how all four disciplines are interconnected. So we first have a picture of the leaf, and that leaf represents the science. So think in your mind, I am a K through 12 educator. What are all the science concepts I can teach about plants and flowers, everything related to plants, the scientific content? The technology is where we have misconceptions. Many individuals believe that the technology is the use of computers only. The technology is any tool that a student puts in their hand. So if a student uses a magnifying lens or a ruler, that is a form of technology. So that's very important, especially if you're living in a country where you have lack of resources and finances. Very simple tools are considered the technology. The third component of STEM is the engineering component. So after the students learn about the plants, they use their technology, they work together, the teacher's going to give them an engineering design challenge. They're going to ask them to build a terrarium. They're going to ask them to plant a garden, but it's something that's going to allow the students to actually engineer. And the last component is the math component. So if we're studying plants and students were asked to plant a seed, we could measure that seed growth throughout the whole lesson using a ruler, a tape measure, whatever. And this slide here is very critical. This is a best practice of STEM education. And what this means is when you develop your STEM learning experiences, you want for the students to see how all four disciplines are interconnected. There's not one discipline that is more important than the other. They are all relying on one another. So as you develop your STEM learning experiences, the students need to see how they are interwoven within their lesson. So is there anyone comments so far about what we've learned so far? Beautiful. Oh, and there's no sound. I know there's some problems. Dr. Manure, are we okay? I see someone says they can't hear. Hopefully you can hear. Dr. Manure, can you hear? Oh.
Yes, Dr. Diana, everything is fine.
Okay, I see comments that people can't hear. Sorry, I just want to be sure. Thank you. So the misconceptions about STEM education. This is critical in our session today because so many people think that STEM is strictly about saying everyone's going to be a scientist, be a computer scientist, an engineer, a mathematician, but that is not what STEM is about. STEM is about providing students with 21st century skills and STEM habits of mind. Not everyone's going to be an engineer. Not everyone's going to be a scientist or a mathematician. So keep that in mind. That is a big misconception. So I'd like to ask you, why is STEM education important? In our Facebook page live, please share with us, why do you think STEM education is important? Even if the student has no desire to become a scientist or an engineer, why do you think STEM education is important? So let's see what we have in our comment box here. Why is it important? Why are you all here this evening? Why is STEM education important? And notice that Dr. Diana is waiting because I want you to be engaged. Oh, 21st century skills. Beautiful, Roselle, beautiful. It helps develop critical thinking. It's real life teaching. My goodness, Dr. Manure, the people here are amazing. It's amazing. I love it. It's real life teaching. Wonderful. What a group of educators we have here today. Beautiful, beautiful. Beautiful. So I have a list here. Look at this is just the tip of the iceberg of what your students will gain from being introduced to STEM learning experiences. And I hope you don't mind, I'm going to just run down this list. There is a global shortage of skilled STEM talent, no matter where you live. The skills derived from STEM education develop and nurture 21st century and social emotional learning skills, which are critical at this point globally due to the COVID-19 pandemic. Innovation sparks general curiosity and creativity, encourages experimentation, teaches problem solving, encourages tech use, encourages teamwork, encourages knowledge application. In simple terms, real world application. STEM is vital to understanding the basics of the environment and the society. As Dr. Munir said in his introduction, it is not just about the book smart in STEM education. We want students to have empathy. We want them to be culturally sensitive. We want them to be innovators to develop things that are needed for their country and other countries that will help their lives be better. So, and by the way, I will give a link to this PowerPoint that Dr. Diana is showing for all participants today. So, wow, look at all of what we can gain when we incorporate STEM within our classroom. So we all need STEM thinking skills, not only those in the STEM fields, whether you're going to be a chef, a baker, whether you're going to be a carpenter, whether you're going to be a farmer, a musician, an artist, a ballet dancer, it does not matter. STEM will introduce you to 21st century skills and STEM habits of mind. And those are the skills that no matter what you choose to do with your life, it will help you be a productive citizen wherever you live. So, what are the 21st century skills? I'd like for you to share in our live fast Facebook page. What are our 21st century skills? So let us do that now. What are our 21st century skills? I love that. Someone said that STEM completes us. I have to write that comment down. That is a wonderful comment. STEM completes us. Whoever wrote that, thank you so much. What a thinker. STEM completes us. I love that. STEM is the future. Mindfulness, beautiful, super. Wonderful. Notice that Dr. Diana is engaging and empowering the participants. Very critical. I want to model how you want to be teaching to your students so that they are actively engaged and find the lessons meaningful. So these are our 21st century skills. You'll often see many more skills added to these four, but we're going to start with these four, and we call them the 4 C's. Notice that each one of these skills begins with the letter C. So critical thinking, creativity, communication, and collaboration. So as you go back to your classroom, you want to design STEM learning experiences that allow the child, no matter what age, to develop and nurture these 21st century skills. So they should be actively developing those skills. And these are the skills that no matter what you choose to do with your life, these will allow you to be successful. They'll allow you to live in harmony with the people around you, whatever you choose to do with your life. Now there's more though. So not only does STEM develop and nurture the 21st century skills, STEM also develops and strengthens these 6 skills you see at the bottom of that slide. So STEM habits of mind consist of the 21st century skills, but also developing curiosity. It's very sad when children enter their first year of school. They're very, very curious before they get into school, and then they go to school and they're in this classroom and they have to sit down, they can't talk, their teachers are cramming information into their minds. They lose their curiosity. STEM allows students to develop and nurture their curiosity. In fact, most of our famous mathematicians and scientists, artists ever that have lived on our planet, they've all made one quote, and that is they've all said, I'm not smarter than the person next to me. I'm more driven, and I have a very strong sense of curiosity. I'm very curious. The other habit that we develop and strengthen is resourcefulness, the ability to use our resources. We also develop adaptation, which is very important. Imagine our STEM, our COVID-19. We have all had to learn to adapt. If you have not learned to adapt as a teacher, you're struggling. If your students have not adapted, they're struggling. It also helps to develop the imagination, and imagination is critical. If you have imagination, you can do anything that you'd like. Also, open-mindedness, and there were several of you that mentioned open-mindedness, and open-mindedness is very important to be able to survive globally and help the people that are part of your life. And lastly, grit and perseverance. Grit and perseverance are essential, and STEM is promoting, it wants students to keep trying, even though they might get upset when you can't make a top that can spin. You get very upset, but the teacher keeps, reinforcing, keep trying, don't give up, Omar, you can do it. So it really does help with teaching grit and perseverance. So I'd like to show you a slide on critical thinking. And critical thinking has been greatly changed throughout the years. The original Bloom's taxonomy was purely nouns. What you see in front of you right now are active verbs. So when we are in our classroom, we have a tendency to teach in this lower level, the facts, regurgitation of information. It is not going to help your students at all to survive in the real world if they've just memorized a bunch of facts that they really don't understand. You have to move your teaching up to these higher levels. The students have to have the ability to analyze. They have to have the ability to apply the knowledge they've learned to the real world. And the highest level is the ability to create. The highest level is the ability to create. So that's what you want to strive for with your students or your children at home. It is about seeing how can we have these young people become innovators. We might just make a spinning top today. The matter is we have become an innovator. We have made a simple spinning top. So that is Bloom's taxonomy revised for you. And again, you will get a copy of this PowerPoint as long as you're well behaved in the session and are actively participating. So a best practice of STEM education is to teach via inquiry-based practices. And I always present an inquiry format. This is what we call a 5E lesson plan. It has 5 components. Our first component is to engage the student. So right now, in a few minutes, I'm going to have you look at your object from nature. So if you don't have your object from nature, go quickly and run and grab it. That's what's neat about virtual sessions, because you can get up out of your chair and go grab something. So get a plant from your home, a rock, a feather, get something that you're going to be able to look at. So inquiry-based teaching, it allows the students to be actively engaged. It empowers them. And that's how we need to be teaching STEM. Not by showing PowerPoints and lecturing and bookwork and teacher handouts and worksheets, but active engagement. So we engage the student first, then we explore. And the explore part of the lesson is where we're going to add tools. So I have a very simple microscope here. In the US, this costs $12. I love this. And I can put my eye down here. I can put it on my flower and I get to see my flower up close. Or I'm just going to use a simple magnifying lens. Or I can add some tools during the explore part. The students are usually working in small groups. They can also be using literature. They're really learning a lot during Explore. It's the main part of the inquiry lesson. The third part is we ask the students to explain. We want the students to share what did they learn about the plants that they were studying. They give presentations to their peers. It's at the third part that the teachers come forward and then share misconceptions. They clarify misconceptions. They also introduce new STEM content. Now, this is critical. The extend part is generally where teachers incorporate the engineering design process. They're going to ask the students to actually engineer something related to the lesson that they've spent a week or a day or two learning about. So we take all of our knowledge that we learned about plants, and then we either plant a garden, we build a terrarium. Look at this neat contraption down here. Isn't that cool? So everywhere I travel around the world, we have too much plastic and we have too many plastic bottles. So instead of throwing those plastic bottles away, use those plastic bottles in your STEM classes for your students to engineer with. Lastly, in inquiry, we ask the students to evaluate themselves, and the teacher also evaluates the students. And in STEM, we try to not have as much paper and pencil tests, but have more authentic forms of evaluation where the students are sharing audio, they're sharing journals, they're showing you what they've learned instead of writing on pieces of paper, which is really purely a lot of memorization. So there is inquiry for you, and it's a very difficult skill. And truly, Dr. Munir, this is a whole webinar in itself, is just to train teachers on how to teach via inquiry. And maybe in a month or two from now, Dr. Diana can just do an inquiry-based session. So we're going to go to our next slide here. And what an audience that we have, so active. I'm telling you, I am so impressed. So we're going to ask you right now, for all of the people that are out there from all over the world, Romania, Pakistan, all over, what are the barriers to successful implementation of STEM education? Why are educators having a difficult time incorporating STEM within the home and within the classrooms? So I want you to share into the Facebook chat area, what are the barriers? Why do some countries have more focus on STEM than the others? So I'm going to wait and I'm going to see what kind of responses that we have here. Beautiful. So let us hear the barriers that we face on incorporating successful implementation. Okay. Oh, big class size, Ren. Beautiful, beautiful. Excellent. Keep sharing, keep sharing. We just had Ren share. That's a very wonderful point, Ren. Big class size. What else? Keep sharing. Oh, lack of pedagogical tools. Beautiful. Resources. Excellent. Corporate cooperation. I love it. I love it. Dr. Munir, you have a wonderful audience out here today. I am so impressed. Big hand for everyone. So, some of the barriers that we face worldwide are listed for you on this slide. Just depending on where you live may affect whether STEM is even considered a facet of education. Maybe your culture influences if STEM can be taught authentically or not. When we live in certain countries, sometimes it is thought of the teacher as being the sole source of knowledge, and the students are very submissive and they're taking notes and they're listening to the lectures. And unfortunately, quality, authentic STEM that's not how we do STEM, and that's not how we learn STEM or teach STEM. The teacher training, the knowledge, the lack of knowledge, stereotypes. What do you envision as being a scientist or an engineer? How we teach. Are we lecturing Or are we allowing students to actually touch tools and actually look at things? How are we teaching? How are we engaging the student? And our resources, which many of you mentioned, resources. And that's probably the most critical component and barrier that causes problems with incorporating quality STEM learning experiences globally is our lack of resources. And lastly, lack of technology. But I want you to realize that Dr. Diana, when I travel around the world to present STEM, I always incorporate low-cost technology because many places I go, they just may have a classroom. That's all they have. So if all we have is a classroom and no tools at all, as a teacher, we must use the skills we have to develop and strengthen the students' STEM habits of mind. And to do that, you really don't have to have any technology or very, very low-cost technology. A simple magnifying lens is considered a form of technology. So I do want you to realize that. Of course, STEM is about the real high-end technology, but it's also about incorporating all forms of technology as well. So let us see what we have here. So what I'd like you to do right now is I'm going to give you a minute, and I want you to gather up an object from nature. So now you get to touch and explore. So right now, gather up your object from nature, like a leaf, a shell. It's in the middle of the night in most of the places where we're viewing this webinar today. Find something from within your home. If you have a plant, bring your plant in front of you. If you have a rock, a shell. So my questions for you are, what do you see? What do you wonder? And what are your questions you have about your object from nature? So what I am doing here is, without any technology at all that you are using, I am asking you to make observations. So we are developing our 21st century skills and our STEM habits of mind simply by making observations and analyzing. So please right now, share in the Facebook, share what you're looking at, share with the group, what are you making observations of, and what are you seeing? What is the shape? Is it living? Is it non-living? What is the color? How does it help mankind? Do we use the object by man? So for example, if you had a seed, is the seed planted and it's used as an agriculture crop? If it's a flower, do we use it in cooking? So make the real world connections. So I'm going to wait a minute because we might be having some lag time in our video here. So I'm going to wait a minute here. So you should have your object from nature. And let us see if anyone has an object. Beautiful. Nadia says it's smooth. Okay, beautiful. Nadia says it's smooth. What is smooth, Nadia? Oh, she has a leaf. Okay, or maybe they're just looking at my object. I'm not sure. I hope you have your own object. The goal is for you to be touching, smelling, and preferably not eating your object, but you could. So anyone else have any observations? Oh, my plant closes its leaves, I think, at night. Oh, a stone. How old is it? So beautiful. So the shape, teaching from real life. Beautiful. Nature in all forms. Beautiful. Beautiful. The shape. Excellent. Excellent. I'm just going to reach over here. I have a coconut, a very large coconut. And this is from Dr. Diana. We grow coconuts. And it's got coconut milk in it. How would I know? Because I can hear the water, the milk shaking inside. It's very heavy. I could put this coconut in a scale and have the students weigh it. I could also take a tape measure and I could get the circumference of my coconut. I could also take this coconut and I could ask the students to make predictions. Do you think the coconut will float or sink? Now, if you have really young students, this is very heavy. they're going to think that the coconut's going to sink. So put the coconut in water and the coconut will float. And the coconut is one of very few seeds that has the ability to float. And what's so exciting about coconuts is you'll find them floating in the ocean all around the entire globe. So beautiful, beautiful. We've got some great participants today. Dr. Manure, you have such a great group here today. They're so actively involved. So in the classroom, when you're back in the classroom, even though you may have lack of resources, you want to try to incorporate any forms of technology you have. And again, it could be as simple as a ruler. It could be an inexpensive microscope. What's very exciting, especially for my teachers that are here today that teach in middle school, high school, and university, you want to incorporate digital microscopes. So this is a very inexpensive one. This is about $35. But in the high school and university, you might use a digital microscope that costs $50 or $100. But the point is, this gets plugged into the computer and the students are able to put this onto the leaf, and then it shows the leaf plant cells will show up on the computer screen. So it's a very effective way to use what little money your school may have. So again, you want to incorporate the technology throughout your lesson. Very, very simple forms of technology. Anything that a student puts in their hand is considered a form of technology. It is not just the use of computers. And this is critical, as Dr. Manure said. It's not just about materialistic things. It's about making your students aware, making them have observations and be aware. A lot of you have said that nature is beautiful. Many of us do not even take the time to stop and look at how amazing nature is. And nature's just amazing. So when you make your observations of whatever you brought today in our session, you want to think critically and creatively. You want to make connections to the real world. That's what STEM is about. It's about not teaching students a bunch of facts. It is about teaching them what is the meaning of why we're learning about leaves. What did man take from leaves? So scientists looked at leaves. They looked at plants. And what do plants have the ability to do? For my scientists out of there, it begins with the letter P. What do plants do? They take in sunlight. What's that process called? What is the process where plants take in the sunlight and they're going to give us oxygen? They're going to take in carbon dioxide. They're going to make water. They're going to make their own food. What is that called? I'll wait to see. Let's get a scientist. Let's get one of you teachers. Begins with the letter P. Dr. Diana doesn't want to tell you. I want to make you be the thinkers. So plants are able to photosynthesize. Plants are able to photosynthesize. Just say that at home. Photosynthesize. So the process of light, and we synthesize. From scientists looking closely at plants under microscopes and looking at the process of photosynthesis, they came up with solar cells. Isn't that exciting? So man looks at nature to gather ideas, to solve problems that man has. That's what STEM is all about. It's trying to provide opportunities for your students to look at nature. How can we look at nature to help us solve problems that mankind faces? Because nature does not waste. If nature wastes, it dies out. It becomes extinct. Man is very wasteful. Nature does not waste. When an animal goes to the bathroom, another animal comes and eats that excrement, or it goes into the ground. Nature does not waste at all. So I'll wait for a moment to see if we have any more comments here. So what I'm going to do, Dr. Manure, you've got such a great group, is I asked everyone to get some bubble solutions. So I'm just going to hold up for what you want to get right now. So you want to get a cup of water that has some dish soap in. A cup of water with some dish soap. So that's what you want to have in front of you right now. So get some dish soap and preferably a clear cup or glass. So you're going to put your liquid dish soap in it. So run right now to your kitchen and get it. I know, no excuses. It doesn't matter be quarantine and COVID-19. Everyone has lots of soap nowadays, right? Everyone's constantly cleaning their hands. You also need to have a straw. Now, I try not to use plastic. There's too much plastic. So I have a bamboo straw, which many of you are coming from countries that use a lot of bamboo. Like if you're from Indonesia, Thailand, India, you're probably using a lot of bamboo now in restaurants and things. So what I want you to do right now is I want you to have your bubble solution in front of you and a straw. And I want you to share with the group on Facebook, what do you know about bubbles? What do you know about bubbles? Please share with me what you know about bubbles. So bubble solution. Okay, Dr. Diana's waiting. I'm not going to give you the answers. We are learning by inquiry. Dr. Diana is modeling best practices. I want you to develop your 21st century skills and your STEM habits of mind. And we're not even using anything that's expensive. We're using things found within the home. Okay, beautiful. So surface tension, Ren, good for Ren. Big hand for Ren. That's the second one I've seen them ask. They look beautiful. It has something to do with surface tension. Another one, Dr. Manure, make sure you do something special for Ren. That participant is amazing, the answers. They blow easily. Bubble has air inside. So we want to say it has the gas inside, solid liquids and gas, rainbow colors. Bubbles are smooth. And I hope you have your bubbles in front of you right now. I hope you have your bubbles in front. So what I want you to do right now is Dr. Diana wants you to blow bubbles with your soap solution and straw. And Dr. Manure said that you should be able to, after our session, you'll be able to add pictures of the experiments you did. So take it with your cell phone and then maybe upload it to the Global Forum page after our session, or you could share it Dr. Diana's Facebook page as well. So right now, start blowing bubbles. Blow bubbles with your soap solution. What do you see? What do you wonder? What are your questions? Beautiful. Okay, so blow those bubbles, blow those bubbles. And Dr. Manure, I hope that they will be able to share their pictures of the bubbles from on their cell phones. So how many of you are making bubbles? Yes, bubbles are free. I love that. They're very cheap. Everyone has dish soap. And also they're helping our hands get clean during COVID-19, right? They reflect light. Beautiful, beautiful. My students love bubbles. They're light like feathers. Okay, beautiful, beautiful. Rainbow, excellent. What a great group you have here, Dr. Manure. I am so impressed. They are amazing. So right now, Dr. Diana is going to do a little, I'm going to show you another slide here. So you can even take your straw and put it into the soap, and you can blow a bubble so that it forms outside of your straw. And we could even measure the size of that bubble. Or your students could, you can put the soap solution on the table and the students can measure the circumference of the bubble. So this is a great lesson to incorporate virtually at home with your students or in your classroom. We're talking very low budget, very low budget. So right now, what I want you to do is I want you to take your straw, everyone. So right now, have your straw, and I'm going to ask you a question. I hope you're listening. You're going to blow into your soap solution, and I want you to share on the Facebook page what shape do you think you will see when you blow into the soap solution? What shapes do you think you will form inside of this cup as you blow into the soap solution? And we're scientists, so we don't really use the word magic. In science, there's always an explanation for it. It's a phenomena. And you might want to jot that down. Phenomena. Phenomena is very, very important. So what we want to do right now is blow into your cup, and I want to see where you're sharing on Facebook. What shapes do you think you'll see in your cup? I'm waiting to see if someone's going to show the shape. I want to see the shape you think we're going to see. Where's the shape? Oh, circle, ovals. Beautiful. Okay. Clouds of small bubbles. Oh, a sphere. Beautiful. I love it because we're saying dimensional shapes. That's where we want to be. Remember, we're STEM training. So once it's dimensional, it's no longer called a circle. It's called a sphere. It's a hexagon, pentagon. Beautiful. So are you ready? So Dr. Diane is going to blow into this cup. And right now, I'm having this in front of the screen. And when Dr. Diana looks, I actually see 2 geometric shapes. 3, actually. I see pentagons, hexagons, and spheres. So most students aren't going to realize that. If you ask them to draw a picture of what they think they're going to see, they're just going to draw a big bubble in their cup. So first you have them make a prediction of what shape they're going to see, and then you actually have them blow into the cup. Have them make the prediction first. So again, I'm going to hold this above the screen here. And the camera, you should see that there are hexagons and pentagons and beautiful colors. And this is actually very complex. This gets into high school and college level physics and chemistry. STEM is about making real world connections. And through this, the students can see that the shapes are interconnected. So if you're a mathematician, think of the word tessellations. Tessellations. There's no wasted space here. So again, participants out there, nature does not waste. Bubbles are inorganic, but they're still part of nature. They're not going to waste any space. Okay, so this is incredible. So for my middle school and high school teachers out there and university level physics people, this is a great lesson. And even starting with my early childhood teachers that are out there. So what are the real world connections? What can we teach when we do lessons on bubbles? We can teach about architecture, mathematical modeling, light waves, gravity, soap film, surface tension, and chemistry. Those are just some of the basics. And I have a picture over here of the swim dome that was built for the Summer Olympics that was held in China, 5-7 years ago or 10 years ago. And notice the dome of the swim dome. The architecture modeled the swim dome in China at the Summer Olympics on the shapes that we just saw in our cup. Isn't that amazing? That's incredible. So I hope that you're finding this so exciting. And again, we are providing opportunities for students to develop their 21st century skills and their STEM habits of mind at a very low cost. And that's what it's really about. It's about making STEM skills available for everyone, no matter your lack of resources, no matter where you live, no matter what sex you are. It's about allowing students to develop these skills with very simple tools, if possible. So this is really exciting. A Japanese scientist, he's an industrial chemist. He was doing experiments with pollination of plants. And in the past, when we pollinated plants synthetically, the plants were injured. So imagine the plants were being pollinated by machinery. It would affect the plants, the parts of the plant, and they would die out and it wouldn't work. So what this scientist did is they actually took like a toy to experiment. They took like a toy blow bubble gun. And when they made their solution, they put the pollen into the bubble solution. So the pollen went into the bubble solution and they squirted that bubble, that toy bubble gun onto the plants, and they pollinated the plant that way. Now they have taken that initial experiment and it's become much more extensive than a bubble blowgun. But look at what we're doing with bubbles in the real world. Is that amazing? And lastly, because Dr. Diana lives on the Space Coast in the United States, Florida, and I think today there's going to be a SpaceX launch today of the Falcon 9. But on the International Space Station, which many of you from all over the world, your people from India, Romania, Poland, China, Japan, the people from your country are on the International Space Station. And not only that, the students you're teaching today, they're going to be the first ones to go to Mars. So as teachers, we need to step it up. But on the International Space Station, they have been conducting experiments to see how bubbles grow in microgravity conditions. So they put them in these containers and they watch them for weeks and weeks, and they look at the air, they look at the gas, but bubbles grow really well in microgravity. And what they do with what they've learned, they take the information they've learned in space and they apply it to what we call foam science. So many things that people use on the planet rely on foam and bubbles. So bubble science in space is very critical. So the next time your principal comes in and says, oh my goodness, I can't believe you're doing a bubble lesson. What can students learn by playing with bubbles? Well, now you have a lot of examples to show your amazing principal just how advanced your student's lesson is. So that's very exciting. So lastly, what you want to do is after students have explored with the bubbles, have the students engineer a bubble blower. And look at this, we've taken straws and then we've taken a tool called pipe cleaners. I don't know if you have those where you live, but pipe cleaners. So we can take the straw and we can cut it into like a tetrahedron and then put this through there. And then we dip our structure into the soap solution, and the students are going to see all the faces and vertices and edges of that geometric shape. And by the way, for my mathematicians that are here today, that is an excellent lesson just on its own. And actually, Dr. Diana has that as a whole separate lesson. So you can have the students build their geometric shapes using bamboo skewers, toothpicks, soaked garbanzo beans. They dip it into the soap solution. And the students, when they take out the geometric shape, they're going to see the faces, the vertices, and the edges. That is a phenomenal mathematic lesson, and it's dimensional. It is not 2D, and that's how you want to design your lessons. Look over here. We have a student who's placed a net on the bottom of their plastic bottle, and as they blow through, they're going to be seeing the hexagons and pentagons. Here we have a plastic bottle and the bubble coming out, and the shape we see there is a sphere. So again, we've incorporated the engineering, we have developed and strengthened our 21st century skills, and we've also developed our STEM habits of mind. Beautiful. So we are getting to our last part of our webinar. We're going to have plenty of time for question and answers, but what you want to have out in front of you now is something that can spin. And you know what? Dr. Diana never got a hold of a fidget spinner, but now I have to go get them because I'm doing a lot of training, teaching teachers about how exciting it is to teach about tops. So Dr. Diana has to get some fidget spinners. But at your home now, if you can try to find something that spins or materials to make a simple spinning top. So give yourselves a minute to go look for those supplies, something that spins, something that spins. And no matter where you're from, boys and girls play with spinning tops. Dr. Diana travels the world, in the richest to the poorest countries, boys and girls and adults are outside using spinning tops. Now, what I love about tops is that we can teach so much from a simple toy. From a simple toy, we can teach so much. And again, as I mentioned, all around the world, boys and girls are playing with tops. And tops tend to be made with the materials that we can find from within our country and our geographical location. Okay, so tops come in all different sizes. Look at this top I have here. So this top I push down. When I push down, it's going to cause this to spin around. I'm going to take this top here. I'm going to look at it and make observations, and I'm going to spin it on this plate here. And you can see that it is spinning on the plate. Wow, look at that. Beautiful. So in our lesson here, what we have is we have the science. So think about what is all the science behind our spinning top? What is all the science, the STEM content we can teach? Our technology is here. I want to show you this top. This is a top that's made of titanium. So it's considered high tech. This top, it has the ability to spin for a long time because of the material it's made up of, and it can also flip over. I'm going to try to spin it. I can't guarantee it will work. Oh, almost. And you see that the top was able to flip on over there. That top is made of titanium. And then the third part of our lesson is the engineering. So what materials at home could a student make their own spinning top? And then what mathematical tools would we use to make our spinning top? Okay. So what I love about spinning tops is that spinning tops have been found thousands of years old. We have found ancient tops that were made from objects from nature, such as the tops of shells and seeds. And no matter where you live, everyone has played with a top. And look at this top here. This top here is made up of interlocking spheres, and it reminds me of a molecule. And when you spin it, it spins so amazing. And this is actually something that maybe a middle school or a high school student could create. So now we want to talk about the engineering design process. And you're going to get a copy of this PowerPoint after the session. So don't ask for a link now. As Dr. Munir says, be on good behavior. You will get, Dr. Diana is going to share the link for my PowerPoint after the session. So this is the engineering design process. And when we incorporate STEM within our classroom, students should have the opportunity to engineer. So I want you to look at this right now, and I want you to compare and contrast the engineering design process to the scientific method. And so this session is an hour and 15 minutes, so I hope people quit asking for the link. We've still got a little more time. Stay focused on our webinar here tonight. So there's so much to accomplish still. So in the Facebook, please share with me all of our hundreds of people that are out there this evening. What do you see different with the engineering design process and the scientific method? So for my scientists out there, what do you see as being different? What do you see as being different? And Dr. Diana's waiting. So my science teachers out there, share with me, what do you see as being different with the engineering design process and the scientific method? Okay, let's see. And Dr. Munir, they are so focused on the link. I'm not sure what's happening here. Okay. So who sees a difference between the engineering design process and the scientific method? Could I have someone share? Could someone share with me the scientific method and the engineering design process? Engineering design process and scientific method. Okay, the creative part, beautiful. I finally have someone that answered. Someone who is more focused on watching the screen instead of their certificate. Beautiful. Okay, beautiful. So in the engineering design process, we ask, we then let the students imagine, we plan. We're working in small groups. We want the students to communicate and collaborate. We then take different materials to create our spinning top. What are materials we could use to make a simple spinning top? The next thing we do is we improve our design. And the scientific method, we do not allow you to change your experiment to get the correct hypothesis. But in the engineering design process, we expect for the students to maybe change up their materials to get that top to actually spin. And then lastly, we communicate our solution. So the scientific method is linear. It's step-based. And in the real world, most STEM people use engineering design thinking process. It's much more real world versus a linear scientific method. So right now, my question to you is, what materials could you use to design and engineer a spinning top? So in the Facebook group, I want you to write down, you're at home right now, what are materials you could use to make a spinning top? So let us see, what are materials we could use to make a spinning top at home? Let us put our thinking cap on. Oh my goodness. And I'm waiting to see, what are the things we could use at our home to make a spinning top? Wood, excellent, Larissa, beautiful. Plastic, iron, beautiful. Beautiful, super. Thank you, Dr. Manure. People are focused on our getting our certificate. I hope you will stay engaged in the presentation. You will get your certificate. Dr. Manure never fails. Okay, beautiful. Aluminum, paper, wood, plastic. So how many of you out there today actually have something you could right now try to make, something that has the ability to spin? Do you have something at home that you could go and collect to make? Beautiful, cardboard, a stick, beautiful. So the next slide, notice that Dr. Diana made you think. I did not put this slide up first. I made my students think first. If a teacher puts the slide up with information, the students didn't have to use their creativity. They didn't have to think critically. They didn't have to communicate and collaborate. The teacher should be making the students think first. Do not provide the students with the information. That does not develop their 21st century skills or their STEM habits of mind. So these are materials we could use to make a simple top. And what I want to do is I want you right now, see, with just what you have at home, can you make something that has the ability to spin? I'm going to give you a minute. At home right now, gather up some materials. What can you gather up that you might be able to? Oh, I like that. Toothpick and Hama beads. Beautiful, Simona. Beautiful. Ice cream container lid. Oh, I want some ice cream right now. Beautiful. Okay. So what you need to do after the session is over, put pictures of your project on the Global Forum Teacher Educators of the homemade top that you built. And you can also put it on Dr. Diana's Facebook page as well. I would love to see that. I would love to see that on my page as well. Lid of a saucepan. So here's some pictures of some very simple spinning tops. Now your students should be able to get these materials at home, at least these two pictures at home. They should be able to have those materials. And I'm just going to show you this top that I made. I took a CD or DVD, a plastic cap, and a marble. And I put the marble underneath, and I have the plastic cap here. and I'll show you that I made a simple spinning top. And it will have a hard time spinning because the surface is not the best for spinning. As you can see there, my top has the ability to spin. And we could also ask the students, what can we do to this top to change how it spins? We could add some Play-Doh or clay. Look at this simple spinning top. Here I have just a broken pencil. So for you teachers, don't throw out the broken pencils anymore. And just a piece of cardboard. A piece of cardboard, and I cut it into a circle. Look at this, watch. And I can't promise because this top's kind of old. I've used it many times. I'm going to try to see if I can get it to spin for you. There you go. You see that? So beautiful. So I think that your students would be able to do that at home. And of course, if they're young, you make it be a very simple spinning top. And the older they are, you get more complex. So we're near towards the end of our session. And I want to ask you, what STEM content can we teach when designing and engineering a spinning top? What do we actually teach? What can we teach when we have students analyzing spinning tops and creating spinning tops, engineering? What are they actually going to learn? So share with us in our Facebook group. What are they actually going to learn? What are they going to learn? And Dr. Diana's waiting. Dr. Diana's waiting for you all. Creative minds. Okay, beautiful. But think about the STEM. Think about the science, the technology, the engineering, and math. Think about the specific science content, the engineering, and the mathematic contents. Circle of life. Okay. The atom structure, very good. Spinning activities, beautiful. Hey, Yamton, spinning can even be used with physics, university level students too, but it's great for young students, like you said. Physics, beautiful. So Dr. Diana is going to show you the next slide. Look at all of the STEM content we can teach students about, from just studying tops, mathematical concepts, shapes, energy, force, motion, friction, rotation, speed, gravity, engineering and real world connections, gyroscopic effect, momentum, ball bearings. Many of you are from countries that you use motorcycles and bicycles. As the students are using their bicycles, when your bicycle doesn't work properly, there's something probably wrong with the ball bearings and the pedals. The satellites stay in orbit because of gyroscopic phenomena. When we throw footballs, the football spins in the air by gyroscopic phenomena. So many different concepts we can teach as we do such a simple lesson. And we're using very little technology. And what we're doing is we're allowing all students from around the world, boys and girls, rich and poor, it doesn't matter what your status is, we are developing and nurturing their 21st century skills and their STEM habits of mind. So what Dr. Diana wants you to do is put up a picture, take it with your phone and put it up on the Global Forum for Teacher Educator page. And then you can also share it to Dr. Diana's Facebook page, which you're going to find out about that in just a moment as well. So we're going to have a question answer time. Beautiful. Conservation of energy, calculus. Good job. Moment of inertia, kinetic and potential energy. Moment of inertia. Beautiful, Bam Smith. Calculus. Beautiful. 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 Excellent, excellent, excellent mentoring. Beautiful, super. Remember, please share the picture of your top that you made during this session on the Global Forum page and or Dr. Diana's Facebook page. So now we're going to be asking questions. This is a time where we're going to reflect. What are the questions you have? And I can't promise I can answer them all because it's hard for Dr. Diana. I won't type, I'll just verbally answer. And what are your key takeaways from today's session? What are your questions and what are your key takeaways from today's sessions? Were you engaged? Were you motivated? Do you realize how important it is to develop 21st century skills and STEM habits of mind, whether the student's going to go into a STEM career or not? So let us have your information now. Oh, I love that solar system. Beautiful, Draga. Circular motion. Beautiful. Thank you for shouting out my name. Yeah, well, you did a great job, Bam. Did excellent. Geography, the seasons, day and night. Wow, Manur, you have an excellent group, and it is literally like 12 o'clock. It's midnight in many of the countries. I can't believe it. I can't believe it. Beautiful. So activity-based learning. And one of the words that Dr. Diana never uses is the word activity. And I don't mean to offend anyone. So what I want you to write down now is the words that Dr. Diana uses with STEM education. Listen very closely. You never heard Dr. Diana say activity ever. The words Dr. Diana uses with STEM, are you ready? Investigation, exploration, and discovery. Investigation, exploration, and discovery. An activity is lower level thinking. It's teacher driven. We know the end result. But an investigation is engaging, it's empowering, it's student driven. Discovering, exploring. So as teachers, you need to have that growth mindset. You are not the sole master of knowledge. There's a lot to learn from the universe and your students. You must engage and empower your students, and you do that through inquiry, and you do that through engaging lessons, not through just showing PowerPoints and lecturing. It's a big transition that we have to make, and especially difficult during remote learning as well. We can do great things with simple materials. Larissa, beautiful. And I think that's about the third. Oh, 2:10 a.m. from Malaysia. Wow, very good, Lok Jahai Hu. Very good, 2:10. Dr. Manur, I am so impressed with your group. I am so impressed. So before we wrap up our session with Dr. Manur, this is Dr. Diana's ways you can connect with me. I have a website here, Dr. Diana. I have not traveled since February towards the end, but when I am able to travel, which I can actually travel to many countries right now, I will travel around the world to provide hands-on, minds-on science and STEM training. That means when I come to your school, we're going to actually be touching and doing. I show PowerPoints, but they're in the background. You are going to be like you were today. You're going to be asking questions. You're going to be down and touching things. I have a Facebook page here, and I would love for you to like my page because you can share the pictures from today on my page, as well as the Global Forum for Teacher Educator page. I have a LinkedIn site, a Twitter page, and here is my email. But just don't send me spam email. I would love to come and visit to your country and to share my passion of STEM education with you in person. So I hope to meet some of you in person someday. Now, what I did tell Dr. Manur is those of you that post pictures of your bubbles, especially your STEM, your spinning top, the first 100 people, I will provide a link on the Global Forum page. I will do a Zoom webinar via Dr. Diana Zoom, just because I have more control of that with the camera, and I use different tools and things of that sort. But I would love to provide a free training, a STEM training about deconstructing and tinkering gadgets. And I will do that for the first 100 people that post their pictures on the Global Forum Teacher Educator page or Dr. Diana's page. Of course, priority is to post it to Dr. Manur's page, but you can also post it on my page as well. I would love to see where all of you came from. Romania, Poland, Indonesia, Myanmar, Thailand, Pakistan, all from out the world. So they have been an amazing group, Dr. Manur. I am so impressed with this group. And I will be quiet. You will get a link to Dr. Diana's PowerPoint. But please do not bother me and ask for it in the session. Dr. Manur's had to scold a couple of you already. Good job, Dr. Manure. I will share a link to the PowerPoint presentation. You may need to modify it because it doesn't always upload properly to the Google. So the only thing I ask of you, if you use it with your university or classroom, that you do not take my name off the slides, because that is Dr. Diana's materials, of course. That's the only thing I've asked of you. So thank you all so very much. You were an amazing group, and I cannot thank Dr. Manure enough for allowing me to share my passion and knowledge of STEM education. And Dr. Manure, we are so grateful for your time and efforts in organizing such an amazing platform to educate teachers virtually with world-renowned educators. A big hand to you, Dr. Manure. And I pray that all of you will remain safe and healthy. And I want you to leave the seminar today knowing that you can incorporate STEM within your classrooms with very little resources. It's about really having that mind grow set that everyone needs STEM skills, whether you're going into a STEM career or not. So thank you. And I will let Dr. Manure take over, and I am just on time. I can't believe it. So Dr. Manure, I'll let you take over at this point. Oh, it is happy. It is Teacher's Day. Happy Teacher's Day. It is October 5th. Beautiful. And Dr. Manure, are you going to do a thank you?
Thank you, Dr. Diana, for a wonderful session. And I'm grateful to you for always accepting our invitation. And I hope that in the near future as well, you will be coming on our platform to share your knowledge with the global teachers. Thank you.
Thank you so very much. Thank you so very much.